We live inside this giant invisible shield. It protects us from all the harshness of deep space. And today, we're going to venture right to the edge of it, to map it for the very first time, all thanks to an incredible new mission called IMAP. Let's dive in.
So what exactly is this cosmic shield? Well, imagine our sun is constantly blowing a massive bubble out into space. This bubble, it's called the heliosphere, and it surrounds all the planets, protecting all of us. And for the first time ever, we're about to map its boundaries in some seriously incredible detail.
All right, so how in the world do you map something so huge and, well, invisible? You send a totally new kind of explorer. Let's meet the hero of our story, NASA's IMAP probe.
IMAP, which stands for Interstellar Mapping and Acceleration Probe, is already out there on its way. It's on a 2-year journey to a pretty unique spot in space, a vantage point where it can study our protective bubble and the whole galactic neighborhood just beyond it.
IMAP has a fascinating to-do list. It's a total cosmic multitasker. It's going to track these super energetic particles blasting away from the sun. It's going to measure the invisible magnetic highways that kind of connect the planets. And it's even going to catch ancient stardust. I'm talking the literal leftovers from stars that exploded across the galaxy. How cool is that?
So all of this amazing science is happening inside a truly colossal arena. And that brings us to the sun's bubble shield itself, what scientists call the heliosphere.
The heliosphere is basically the sun's domain. Think of it like a giant protective bubble that our sun's solar wind inflates out into interstellar space. This bubble is our #1 defense, shielding us from the most dangerous high-energy radiation coming from the wider galaxy. But here's the thing. The mission is even bigger than just mapping our own bubble. This quote from NASA really gets to the heart of it. A key goal is to understand the frontier, the exact place where our solar system ends and, well, the rest of the galaxy begins. How do these two totally different environments talk to each other?
This slide breaks it down perfectly. These are the two big mysteries IMAP is designed to solve. First, how do particles from the sun get supercharged with so much energy? Scientists have theories, but IMAP is going to get the first direct proof. And second, what actually happens in that chaotic zone where our sun's bubble smashes into the stuff between the stars? These are some of the biggest questions in heliophysics.
But there's a real sense of urgency to this mission. It's not just for pure science. It's launching at a time when our star, the sun, is becoming much more active.
For a really long time, the sun was kind of sleepy, relatively quiet. But about 16 years ago, that started to change. Now we're seeing the steady and pretty significant increase in solar activity, and that trend is absolutely continuing today. And here's why that matters. A more active sun means more dramatic space weather. We're talking bigger solar flares, these intense bursts of radiation, and we're seeing more solar storms, which are these colossal clouds of solar material, literally billions of tons of plasma getting hurled out into space. And this isn't some far-off theoretical problem. That #1 you see on the screen, that represents a single, powerful solar flare that erupted just recently. It was so strong that it actually prompted warnings of radio blackouts for hours, right here on Earth. The threat is real, and it's happening now.
Okay, so this is precisely why the IMAP mission matters so much right now. It's all about getting better at predicting these events so we can protect our technology, protect our astronauts, and hey, make some incredible new discoveries along the way.
Yeah, IMAP isn't just collecting data for scientists to study years from now. No way. It's a frontline sentinel. It's sending back a constant stream of near real-time observations, acting as an early warning system for space weather forecasters. It's turning raw data from space into intelligence we can actually use.
This slide really puts it all into perspective, doesn't it? On the left, without this kind of data, we're just flying blind. Space weather is unpredictable, our astronauts and our critical satellites are at risk. But with IMAP, on the right, we get advanced warnings, we get alerts, we can take protective measures, and at the very same time, we're unlocking brand new insights into how our universe actually works.
And get this isn't some future benefit we have to wait for. It's happening right now. The mission just got started, and its data is already being used by NOAA's Space Weather Prediction Center. That's an immediate return on investment for our safety.
So the IMAP mission is out there, charting our solar system's boundary at a super critical time, just as our sun is waking up and really testing that very shield. It leaves us with a pretty vital question to think about. As our sun's activity keeps growing, what other cosmic frontiers are we going to need to map to keep ourselves safe in this vast neighborhood of ours?